Hello and welcome everyone to the 2021 Innovative Student Engineer of the Year Award and the Innovative Graduate Engineer of the Award, kindly sponsored by Siemens. My name is Michal Gallagher and I will be one of your hosts today. I think it's incredible that we had the opportunity to run both these awards this year, seeing as there was no innovative student competition last year due to COVID. So we're really thankful to our sponsor for kind of giving both the class of 2020 and 2021 the chance to be recognized for their innovative projects. I'm joined by our co-host, Pierre. Would you like to introduce yourself?
Yeah, thank you, Michal. So pleasure to meet you all. My name is Pierre Yimberg. I'm also from Engineers Ireland, and it's a pleasure to have you join us today for this very special competition sponsored by Siemens. It's a privilege and their support to continue this innovative engineers competition over the last 20 years. And it's great that we could at least host it in this kind of hybrid setting this year. So we have a big agenda coming up over the next couple of hours. So firstly, we'll just speak from ourselves on Engineers Ireland offerings, and then there'll be a few words and a welcome from our sponsors. And then we'll get into the fun stuff from their presentation by our 5 finalists, which was a tough one that had to be shortlisted, but these are the top 5 that made it into this final round for 2021. And then from there, we'll be moving into actually a live Zoom, which will be the link will be shared with you in the chat. From there, the participants will be grilled and questioned on their presentation and their projects from our 3 esteemed judges. And from there, you can see it from all the participants engaging in their questionings. And then while the judges are deliberating, then we have a presentation by our 2019 winners, the Cutter brothers. So they'll be speaking about their experience and where they've gone on since winning that competition back in 2019. And then we'll round it off then with the announcement of the winners for this year's Innovative Students and Innovative Graduate Engineer of the Year Award. So that's the plan over the next couple of hours, and we hope that you enjoy that.
Yeah, thank you, Pierre. Yeah, it's so exciting to think that in just a little under 2 hours, rather, we're going to know who the 2 winners are. And just for a little bit more detail on who the presentations are going to be done by today, to give you a bit of an introduction to the teams. So these first 3 up are for the Innovative Student Engineer of the Year. And we have Kian Dalton from GMIT with his Aqua Glow vessel. That's then followed by a team led by Mia. And Mia also has Matthew and Siddharth from Trinity in her team, and Antonia from King's College London, and they are known as Fiki Labs. The final finalist of the Innovative Student Engineer will be Tim Farley's team. That's a team mixtures of Tim and David from Trinity, as well as Omar from Queen's University Belfast. They're going to be presenting on their project Field of Vision. We then move into the graduate side of the competition, with the first presentation by Barry Mulvey, who's a UCD graduate with his NIRS food fat sensor. And the final presentation of the graduate side of the competition will be done by Brendan and his multi-college team consisting of himself as a UCD graduate, Ronan from NUIG, and Evelyn from TU Dublin. So they'll be presenting on the project BioWave. Pierre, back over to you.
So that's the way it's going to run and the participants for this year's competition. But just quickly, we want to let you know about the Engineers Ireland offering. So for those who are our current members and our graduate members, especially, don't forget that this counts as one of your CPD hours. So you'll be learning and enjoying and learning from those in the innovative area. So make sure you go into your membership board and dashboard and log in your 1 hour CPD, because you know that you have to at least make up at least 35 hours every year. So this is one down for you. So make sure you do log that today.
You're so right. You're so right, Pierre. 1 down, 34 to go. For those of you who are watching and you've yet to finish your college career, make sure you have a free student membership profile. There's a link in the description if you haven't done it so far. It takes only 2 minutes, and I definitely recommend becoming a student member before you graduate. It's really well worth your time. If you are a student member and you're graduating this year, you should really get around to becoming a full member. So once you graduate, you become a full member of Engineers Ireland. And again, it's completely free to do so. Pierre, do you want to talk them through the graduate membership?
Yeah, so just on the last point then from us on this is that, yeah, if you're either a graduating member or you've just recently graduated, make sure you transfer over to as a graduate member, which is free. And then you can see from there over your next few years, as Engineering Ireland is about investing in your future career and your development. We're offering over €700 worth of discounts. So make sure you sign up for that. And if you have any questions at all, just email us at membership@engineersireland.ie. So once again, we look forward to hopefully enjoying this presentation and competition today. So bring you back to Michal then to get us kick off.
Thank you, Pierre. Yeah, look, this is going to be such an exciting hour. I'm really looking forward to everything coming up. But before we get there, I want to introduce one of our sponsors today. That's Michael O'Connor, Communications Managers at Siemens. And Michael O'Connor and Siemens have been supporting and sponsoring this competition for over 20 years now. So I'm going to pass over to Michael for a few words from him.
Thank you, Michal. Good afternoon, everybody. These awards celebrate innovation excellence among third-level engineering students across the island of Ireland. And we in Siemens are delighted that the competition is back this year and that it's in a new and innovative digital format. The topic of innovation is as relevant today as it was when we first sponsored the awards over 20 years ago. The awards provide a platform for third-level students and graduates to showcase engineering innovations to help solve real-life problems and challenges. At Siemens, we value collaboration and cooperation. So we're once again delighted to partner with Engineers Ireland in celebrating the work of our inspirational student and graduate engineers. So I'm really looking forward to the presentations from really out-of-the-box thinkers, people with growth mindsets, demonstrating innovation and creativity. Thank you very much.
Thank you very much, Michael. And we're actually going to have a quick video from Siemens just as we get ready for our first presentation. So thank you so much.
Disruption, transformation, and opportunities are everywhere. Who will stay relevant, adapt, and grow? At Siemens, this is our answer. With technology, we create impact and value for our customers, addressing their major challenges to master digital transformation, increase sustainability, and adapt to rapidly changing markets. In industry, infrastructure, mobility, and healthcare that are forming the backbone of our economies and societies. As a focused technology company, we combine the real and the digital worlds to help our customers become more efficient, more resilient, more sustainable, and ultimately, more competitive. Making the places where we live and work smarter. Making the movement of goods and people more efficient. Making manufacturing more flexible and productive. Making healthcare more effective. And making our future sustainable. A company driving digitalization. A company empowering its customers. A company transforming the everyday. Siemens.
So thank you very much, Michael, and for that really interesting video. It gives us an idea of what Siemens does. So now onto the really interesting part now is seeing all the great participants' projects now. So starting off, we have Kian Dalton from GMIT, who's going to present to us his project called Aqua Glow Vessel, which is about using a robotic tool that can clean up rubbish in our rivers, which is a really innovative idea that's probably really much necessary in this time of trying to be more sustainable and a cleaner society. So that's Kian is now going to present to you his idea.
Hi, my name's Kian Dalton and I'm an engineering graduate from the GMIT in Galway, and I'm here today to talk to you about my final year project, which is the design of a waste removal robot for marine waters and rivers. I have named this the Aqua vessel. From the beginning, it was important to outline the aims and objectives of this project, which was to research the problem of floating litter around the world and the current technology that is available on the market to deal with this. Then to design a cost-effective and ergonomic litter removal system, and from here then to compile concept sketches and decide on a final design. A prototype was then also produced and tested. 2.01 billion tons of waste across the globe were accounted for in 2016. This is then estimated to rise to 3.4 billion in the next 30 years if something does not change. 242 million tons of this was plastic alone, with 8 million tons being found in waterways each year. With regards to existing removal techniques, we have volunteer work, boats and catamarans that are especially designed to collect this waste, and also a new technology of surface vessels have been introduced onto the market. From my research, I came across the Wayshark surface vessel, which was created by RAN Marine Technology. This is an autonomous surface vessel which can be found operating in Dubai, South Africa and the Netherlands. It has a price range of anywhere from $17,000 to $23,000, depending on whether you go for the remote controlled model or the autonomous model. So in innovative aspects of the project is the fact that it has the ability to function on water while also being watertight. It's easy attachable and detachable basket, which is easy for the user to use. It's compact design, and also its Bluetooth compatibility, which can then be controlled via a mobile app. So throughout the different stages of my project, I related back to Eppinger's methodology, which consisted of planning, concept development, architectural design, detailed design, testing and refinement, and then finally production design and ramp up. As you can see here to the bottom right, this is in the testing and refinement stage where my prototype is operating on the water collecting rubbish. Moving then on to the design. So my first design was a very simple shape. As you can see, not very aesthetically pleasing, but the box shape meant that it could be easy to manufacture. It also had no removable basket. All the waste would be collected within the housing of the actual vessel. Then the second design is a more complex shape. The aesthetics have been improved and is more hydrodynamic, which allows it to glide easier through the water, and also has the added removable basket. The final design then was based off the second design with some more refinements, including a larger basket and also side ballast then, which would allow it to be more stable in the water. For the prototype manufacture then, started off with some polycarbonate sheeting, which was marked out and cut. The shapes were cut to different sizes. These parts were then bonded together using an adhesive. Once this was done and fully complete, a wire mesh was used to create the basket. This was then tied together and fitted to the inner cavity of the vessel. Once it was then fully assembled, it was primed with 2 coats of primer, and 3 coats of the luminous or fluorescent paint was applied to give it that orange colour. Once this was all done, the motors and the circuits were fitted accordingly. So with regards to the technical analysis of the project, the calculations were then based off the Creo model, and the weights and the volumes were also acquired from this. With regards to the buoyant force, it was calculated by getting the density times the volume times the gravity. When it is fully laden, the buoyant force is actually greater than the weight, and this also means the center of mass is then below the center of buoyancy, and it shows that the vessel is able to float and that it also can collect waste without sinking. A 3D printed model was created. Obviously it was a scaled down model. This took a total time of 10 hours to print, and it was made from PLA plastic. The components were then bonded using an adhesive, and it turned out that the model floated accordingly to the calculations that were worked out. So moving then on to the circuitry and the coding for the prototype, DF Robot Romeo BLE Mini circuit board was used, which has the added advantage of the Bluetooth compatibility, which this then, once coded, can be controlled via an app. It is ran on the Arduino software, where the coding commands can be introduced from libraries situated within the software. After multiple tests and trial and error, the motors can then be connected, and a successful circuit will then follow. As you can see here, this is me operating the motors from the circuit board with the app on the phone, and it worked quite well in the end. So then moving on to the potential market is the County Council, EPA, wildlife activists, hotel owners who may have small ponds or moats or marina around their premises, and then also private consumers who may have ponds or pools alike. For the cost of the vessel, it was estimated that the total cost for the parts would come to about €917. This was estimated off the weight by the amount that the cost of PLA at the present time, and then also the labour costs were introduced, which brought the total to €1,401, and then an estimated selling price was estimated, which was €4,500. So potential future prospects for the vessel is to introduce a method of collecting water samples, introduce a UV light which could be used to reduce algae buildup on lakes or marinas or near harbours, and then also to create a fully autonomous vessel with a docking port which would allow users to leave the vessel at the lake to charge and to then be released again to collect waste, and then also finally a water pH tester. I'd like to thank you all for listening to my presentation, and I hope you enjoyed this presentation on the Aqua vessel.
So thank you and congratulations again to Kian for making the final. So that is Kian Dalton from GMIT with his Aqua vessel project. So what do you think about that, Michal? How did you find that?
Yeah, Pierre, I thought it was really cool. I definitely think it was very innovative. I always love when the innovative student of the engineer competition kind of overlaps with people who are trying to make like a good impact with the environment. And so speaking of which, a nice transition into our next presentation. We're now going on to Fiki Labs, and so this is a team led by Mia, and also including Matthew, Antonia, and Siddharth. And yeah, their interesting innovation involves making plastic in a more sustainable and environmentally friendly way. So over to you, Mia, for your presentation.
The effects of climate change are getting harder to ignore. More and more manufacturers are trying to switch to sustainable materials. Yet out of all materials, very little progress is being made with plastic, one of the chief polluters by weight. As such a ubiquitous and essential material in the modern world, sustainable plastics today are few and far between. Why is this? Well, in general, increased sustainability in a plastic correlates with a decrease in strength and durability. And in most applications, these properties simply cannot be sacrificed. You don't want to be driving down the M50 when suddenly your tires biodegrade underneath you. So we at Fiki Labs are here to fill this gap, providing sustainable plastics that maintain high performance. Here at Fiki Labs, we're developing Fiki Plastic, a recyclable thermoplastic with a negative carbon footprint. It is a drop-in solution for manufacturers, requiring no additional infrastructure. This allows for the most efficient carbon emission reduction, while delivering the same material properties as its traditional counterparts. So how is it made? We use CO2 from the air, captured either directly or through algae, and then we use a variety of chemical processes, which we intend to patent, to isolate the desired molecules, and from there make our plastic. This way, we are actively reducing the CO2 in the atmosphere. So while a kilogram of plastic generally adds 5 kilos of CO2 to the atmosphere, our product actively removes 3 kilos of CO2. This reduces carbon emissions by up to 160%.
At Fiki Labs, we are developing a 3-point state-of-the-art chemical method, which is clean, sustainable, and environmentally safe from the very first step until the last one. The first step towards the production of Fiki Plastic is computational simulations. We utilize artificial intelligence to simulate the traditional experimental methods in the computer. During this process, we run molecular dynamics and quantum mechanical computations and analyze the energetical properties and optimize geometries from a nanoscale to macroscale. This allows us to validate the experimental method with accuracy and optimize the properties of icky plastic while eliminating harsh and toxic chemicals in early-stage traditional experimental procedures. The second step is an innovative aquaculture solution where we introduce microalgae and a suitable green catalyst into the chemical reaction that speeds up the process. The longevity of the catalyst allows us to use it for over a decade, minimizing experimental costs and any possible environmental threats. Finally, we form Thicky plastic. Thicky plastic is polyethylene, which is the most common plastic in use today, with the only difference that it is eco-friendly and, of course, carbon negative. This revolutionary procedure is easily scaled up with minimal experimental costs while minimizing greenhouse gas emissions.
Currently, the global plastic market is valued at $580 billion, with a sustainable sector responsible for $80 billion and growing at over 7% year on year. We're targeting the automotive and construction material industries, where material properties cannot be sacrificed. In terms of competition, this is how we beat them. Thicky plastic offers a negative carbon footprint, works with existing machinery, requiring no additional infrastructure, is recyclable in line with the EU vision of circular economy, and on top of that, provides the durability that our target market desires. We have two routes to market: manufacturing and licensing. From our discussion with potential customers, we found that they would be willing to pay $2,200 per ton for thicky plastic. We're aiming to achieve a similar price, including an industry average 18% gross profit margin. The first year of Thicky Labs will be a developing phase and are conservatively estimating sales of thicky plastic to be €100,000 in year 2 and $500,000 in year 3. The licensing route involves leasing the formulation out to large chemical companies like BOSS, which is commonplace in the chemical industry.
So who are we? We are high-achieving engineering and chemistry students and friends on a mission to combat carbon emissions. As a team, we have vast experience from management consulting at McKinsey to researching sustainable concrete and weight reduction techniques at Trinity and novel organic chemistry conversions at King's College London. And despite being separated across an entire continent, we've accomplished a lot over the past 3 months. We've been working hard to build up and continually add to our advisory board of industry-leading experts in the plastic, aquaculture, and scientific research space. They've provided us with industry insights and advised us on multiple difficult decisions throughout our journey so far. With their help, we have honed the skills to bring Thicky plastic to market successfully. We formed a strong partnership with Boyd Escobar, have secured substantial funding and business mentoring through Trinity's Launchbox Student Accelerator Program and Blockstone Launchpad Fellowship. And through Antonia, we have secured all-access lab space at King's College London, which will allow us to start our prototype trials, taking Thicky Labs to the next exciting level of development. So what's next? Next month, we start prototyping in KCL. At the same time, we'll be securing corporate contracts from clients in the automotive and construction space. Based on feedback from potential customers, we will refine the Thicky plastic properties with the goal to have the initial MVP ready by March 2022. Our first trial manufacturing run is planned for September 2022, for which we require investment of €250,000. Following this, we will seek further equity investment to expand production, which will gear us up to disrupt the plastic industry. We are Thicky Labs, on a mission to help companies reduce their carbon emissions by providing the future of plastics. Thank you, and we welcome any questions.
Thank you, Matthew, and of course, thank you as well to Mia, Antonia, and Siddharth for a really fantastic and engaging presentation. Really enjoyed the fact that we're kind of keeping on that environmental theme for now, and yeah, like really incredible presentation, and I'm wishing you all the best of luck. Pierre, what do you think about that one?
Yeah, no, I agree with that. It's great to continue to see more environmentally innovative ideas being brought forward. I think this is the time or the moment that when we bring up or think of innovative ideas, that they can also have a positive environmental impact, and it's great to see that from our innovative students, engineers out there. So I'm eager to see how this idea follows through over the next couple of months and years for sure. So So, and then on to our third and last of the Innovative Student Engineer of the Year category. We have Tim Charlie from Trinity, along with David also, and then the presentation brought to you by Omar from Queen University Belfast. So a team of 3 on their project Field of Vision, which is an idea and concept to make football and the beautiful game more interactive and accessible to the visually impaired. So really interesting idea, and I'd love to see how that works out. So here we go, brought to you by Omar.
Hi, my name is Omar and I'm a final year aerospace engineering student at Queen's University Belfast. I've always had a huge passion for engineering, doing big projects in secondary schools such as F1 in schools or SciFest, and in college working on the likes of Formula Student or robotics competitions. I'm also a massive football fan and a fan of all sports really. Last year I combined these 2 passions and started Field of Vision, a project along with my close and capable friends Tim and David. Our mission at Field of Vision is to give professional sports clubs and stadiums the tools to make their live games not only accessible to visually impaired sports fans, but also as immersive and enjoyable as possible. We do this using both haptic hardware and AI. A couple of weeks ago, we installed our AI cameras in Dalymount Park in Dublin to begin our first pilot program of our tech and to get it into the hands of passionate football fans across the city. The only way that over 100 million blind or severely visually impaired people worldwide can experience live sport is through commentary or a friend or family member. We've spoken with blind football fans across the world and they say the same thing. Commentary, no matter how detailed, cannot truly convey the excitement, intensity, and thrill of a live game. More so, they continuously rely on someone else's senses, someone else's interpretation of the game, rather than their own. Finding this video here, and many more like it online, is what inspired us to start Field of Vision. A blind man and his best friend watching a live game together, using their hands and a board to convey the action in as much detail as possible. Not every blind fan has an amazing friend like this, but not every blind fan should have to rely on one. As strange as it may sound to an outsider, when we watch our favourite team play a big match, we feel as if we're on the pitch with them, egging on every pass, tackle and shot. I couldn't imagine a life without this feeling, and this is why FOV exists. So we've built this, a small, portable, haptic-based device which enables visually impaired fans to track the movement of the ball on the pitch in real time, along with other key details through multiple levels of vibration. We use computer vision to track key data about the game in real time, such as the ball's position on the pitch. For now, this is done by installing a camera in each corner of the stadium. Match data is processed in real time on the edge and then sent to the cloud for triangulation and merging, before being sent to the device in the user's hands via Wi-Fi or mobile data. Depending on the network environment, this can be done in less than half a second. This is all then broadcast to the device in the user's hands, where a movable ball on the top surface moves the user's finger to any position on the pitch, reflecting what's happening on the field in front of them live. Haptic motors communicate which team has the ball and what they're doing with it. For perhaps the very first time, our users can feel the swerve on a free kick, the power of a shot, or the strength of a last-second tackle. The device itself features a custom-designed printed circuit board based on an ESP32 microcontroller. It has both Wi-Fi and Bluetooth connectivity for receiving match coordinate streams from our cameras. The board controls 2 stepper motors which drive timing belts to move the ball to any position on the XY plane with speed and accuracy. It also controls a number of vibrating motors to give the user additional sensation based on what's happening on the pitch. Hall effect sensors are used to calibrate the position of the stepper motors each time the device is powered on, so that it can operate accurately in an open loop system. Here's a brief overview of our main computer vision objectives and some of the challenges they pose in order to make our solution possible. Tracking the football is an interesting task. It generally has a consistent size and shape, small and circular, but it also moves pretty fast, creating a motion blur, and when it's kicked, its shape can be distorted. It is also generally viewed above a green grass pitch with a pretty good contrast, but it can also be frequently occluded by players. In the past, people have found pretty reasonable success in tracking the ball using classical computer vision techniques, but they weren't very robust. However, deep neural networks have allowed for a new paradigm to tackle this problem with considerably more success. Our setup is pretty straightforward. We install 4 camera units at each corner of a football pitch. Each unit is fitted with a high-resolution camera, LTE capabilities for networking, and an NVIDIA Jetson Nano compute module, an on-the-edge computer that allows us to run our AI model. The first step in locating the ball's position in real-world coordinates is object detection. And for this task, there are many general purpose object detection algorithms readily available and open source by big names like Google and Facebook. And they cater for many different needs. The most popular algorithms are very general purpose and accurate object detectors, but they're not necessarily optimized for high speed on the edge computing. Yet we learned early on that none of these would work for our use case. Using even the smallest and fastest open source algorithm, MobileNet, we found that we could not reach the accuracy and speed required to detect the ball in high resolution images. This is primarily because these detectors are built to be flexible and general purpose, designed to be only to detect things of all different shapes and sizes, but we only needed to detect the football. Because of this, we developed our own computer vision model. Taking advantage of the fact that we know the ball's general size and shape beforehand, we're able to treat the ball detection task as a scaled down segmentation task. We split the image into a large grid like a chessboard with many more squares, and then just tried to predict the probability of each square containing a football. This is a much simpler algorithm for ball detection, and also considerably faster and more accurate when compared to other lightweight object detection algorithms. We have a diagram here which shows the general architecture of our model. It is a convolutional neural network. We combine feature maps from each layer of the grid. This combines the information from different layers within the network, feature maps of different granularities, and learns which layers of feature maps are most important. This is important because it means we don't lose information from early in the network, which is particularly important for locating small objects. Our network is very small, with only 400,000 parameters, which is about an order of magnitude smaller than the most lightweight mobile net architecture available, whilst being considerably more accurate. It is also very fast, able to run in real time on our edge devices, the Jetson Nanos. After each camera detects the ball, we then compare the detections in order to locate the ball's real-world position using triangulation. We project the ball down onto the football pitch using a homography transformation. We also know the position of each of our cameras in the football stadium. What we can then do is compare the different rays between cameras as shown in the diagram. Where the rays are closest together or with perfect conditions where they intersect is where we can take the ball to be. We're currently beginning our user testing of our system and product, and we look forward to developing it further and further over the next couple of years. Thank you for listening.
Thank you to Tim and his team from Trinity and Queen's University Belfast on their project Field of Vision. Really was a really interesting concept. As an avid fan of football myself, it's great that the game, the beautiful game that we call it, can be a bit more open and accessible for more people. So I'm really interested to see how the rollout of this runs over the next couple of months and years. So what's your thoughts on that, Michal, yourself?
Yeah, Pierre, I thought it was incredible, and I think that engineers all over the world make people's lives like better in so many ways. Like I always think of the biomedical engineers who are doing different things, like you know, engineering limbs for people who are amputees and everything. But I do see this as an extension of that. Like they're making something more accessible to people who want to enjoy the beautiful game. So yeah, I think that was a fantastic one. And yeah, that was the third of our 3 Innovative Student Engineer of the Year competition finalists. So now onto the next segment of it, which is the Innovative Graduate of the Year award. And there are 2 finalists in this. And the first one will be Barry Mulvey, who's a UCD graduate with his NIRS food fat sensor, and we're handing it over now to Barry to present on his entry.
Hello, and welcome to my entry for the Innovative Graduate Award. My name is Barry Mulvey, and I'm presenting my master's work on the determination of fat content in foods using a near-infrared spectroscopy sensor. This project builds on existing technology through my development of algorithms to determine the fat content of dairy spreads. I chose spreads because they are an everyday food which vary in their levels of fat content. Dietary fat is a major risk factor for cardiovascular disease, or CVD, which is the leading cause of death globally and is a huge financial burden on healthcare systems. It accounted for 31% of deaths in 2016, which is projected to increase to 45% of deaths annually by 2035. The aim of this work is to determine if it is possible to accurately measure fat concentration in foods using near-infrared spectroscopy in a handheld sensor. CVD refers to conditions that involve narrowed or blocked blood vessels that can result in heart attacks, angina, and strokes. A major risk factor for CVD is dietary fat, and if this can be identified in food by the consumer, then it can be avoided. The World Health Organization has estimated that eliminating health risk factors for chronic disease, including unhealthy diet, would prevent at least 80% of all heart disease, stroke, and type 2 diabetes, and greater than 40% of all cancer cases. There are laboratory instruments which can determine material chemical makeup, but these are typically costly and bulky. The application of the innovative algorithm to a cloud-based handheld sensor would enable consumers to measure the fat content of their food at the points of purchase and consumption, and thus change their diet accordingly. Successfully doing this for dairy spreads suggests that this can be expanded to other foods. Near-infrared spectroscopy, or NIRS, is based on molecular overtone and combinations of bond vibrations. NIR light is emitted from a source towards the material being examined. Some of the light is absorbed, some passes through, and some is reflected back towards the source. And this reflected NIR light can be measured at the source and analyzed at different wavelengths to determine the spectral fingerprint of the material. Irs instrumentation is generally comprised of three components: a source, a detector, and a dispersive element. Examples of these are shown. Popular broadband sources include halogen light bulbs, LEDs, lasers, and frequency cones. Detectors are commonly silicon charge coupled devices, or CCDs. The dispersive element is usually a diffraction grating or prism. There's been substantial growth in popularity of health-based devices recently, and NIRS sensors are emerging as cutting-edge technology for personal and commercial use. The main route to market for this algorithm involves partnering with a sensor manufacturer to enhance an existing device. I chose to focus on dairy spreads since they have a range of fat content, they haven't previously been assessed, and they're not included in the chosen sensor's model database. The raw reflecting spectra of these spreads are overlapped and interleaved, meaning that there is no perceptible difference in the level of fat content. Using machine learning classification with the random forest algorithm results in low accuracy in distinguishing between the various spreads. To overcome this, I designed different algorithms to compensate for measurement irregularities and errors and to exaggerate differences in the spectra. Examining one of these in greater detail, this algorithm normalizes the data to compensate for the possibility of changing measurement conditions and for optical path differences. Processing the raw spectral fingerprint with this algorithm produces the following result, where there is now a perceptible difference in the process spectra, and we are able to distinguish between the different materials. Using machine learning classification, the ability to distinguish between samples now has an accuracy of over 99% with this algorithm. The next aim is to ascertain if it is possible to determine the amount of fat in different foods using NIRS. This is achieved by examining the spectral fingerprints of materials which vary only in fat content. To do this, I employed the method of gas chromatography with flame ionization detection, or GCFID, to obtain the fatty acid composition of spreads. According to the GCFID analysis, humidic acid is the most abundant saturated fatty acid in dairy spreads. To investigate whether levels of fat can be identified using NIRS, I generated a calibration curve or standard addition method with humidic acid as the standard. The values are chosen at appropriate points within the fat concentration range of the spreads examined. By analyzing plots of the resulting spectral fingerprints, we can determine if changes in the humidic acid concentration result in changes in the spectra. The resulting spectral fingerprints are plotted where the legends indicate the fat concentration added. Examining these results, the raw reflectance spectra are again overlapped and interleaved, and there is no difference in the level of fat content. After processing the raw data with the algorithm, resulting plots now show a clear sensitivity at 920 nanometers, where the amplitudes of the peaks increase monotonically with concentration. These results demonstrate that I have successfully determined fat concentration in these foods with a handheld cloud-based near-infrared spectroscopy sensor. The development of this sensor would enable consumers to influence their own dietary choices at the points of purchase and consumption. This could have major benefits for both the individual and society at large, enhancing health and quality of life. Thank you very much for your interest and attention.
Well, thank you, Barry. That was a really fascinating presentation, and one I think is incredibly innovative. And yeah, I thought that you had really cool graduate research on that topic. So Pierre, do you have any thoughts on our first of 2 entries of the Graduate Engineer of the Year competition?
Yeah, Michal, yeah, definitely agree. That definitely presentation by Barry has definitely left some food for thought. But really on a serious note, I think it's a great way to showcase, like, as everybody's become more conscious on the food that they eat and their consumption of sugar and fats. It's a great way that people can be mindful and have a more hopefully opportunity to keep an eye on their fat intake on a more regular basis. So really interested to see how this works out, because I'm sure it's going to be a massive help to those in the health and nutrition industry. So so that's our second of the Innovative Graduate Engineer of the Year category. Now on to our second one and final one presentation of today, which is by Brandon Blacklow with his team from UCD, NUI Galway, TU Dublin, and their competition or their project is BioWave. So really an interesting way to, again, make playing computer games and games in general more accessible for those who may not have had the opportunity to do so due to the inaccessibility of the controllers available at the moment. So this is Brandon's project, and so he'll show you what it's all about.
Hi there, my name is Brandon Blacklow, an electronic engineer from Galway. I finished my Master's in Electronic Engineering in UCD in August 2020. This is just after finishing my Bachelor's in Biomedical Engineering, also from UCD. After I finished my Master's, I went on to co-found BioWave, where we build modular video game controllers for people with disabilities, but also for everyone that just wants a customized controller for their own personal need. When myself and my co-founder Evelyn O'Riordan were kids, we used to play video games together all the time. After school, we'd go straight over to each other's house and play Shrek on the PlayStation 2. Myself and Evelyn went our separate ways in life, and we just reacquainted last year. I was really saddened to hear that Evelyn couldn't play video games the same way she used to be able to when we were kids. This is because of her disability, Ehlers-Danlos syndrome. She cut her right hand, and the nerves never regenerated correctly to allow her to use generic video game controllers. So despite Evelyn being an award-winning game designer, she couldn't use a lot of the generic controllers that exist to play her own video games. I thought, this is not great, and being an engineer, there must be a solution for this. So with Evelyn's amazing creative skills and my structured engineering skills, we came up with a solution, which is the Proteus modular video game controller. So before I get on to the solution that we created, let me introduce you to the team that has engineered it. So it started off with just myself from UCD and Evelyn O'Riordan from TUD. We decided we would do anything to make this controller that we ideated into a reality. So we went out to win as many awards as we could to give some credence to the idea. We were working in the attic of my dad's office at this time, taking advantage of anything we had around us to make this startup as lean as possible. Once we gained this credibility of 3 different awards, we were accepted into the innovation hubs in GMIT, who saw the great potential in our device. It's at this stage that we brought in Ronan Murphy with a Master's in Artificial Intelligence from NUIG. With a single 3D printer and all the breadboards and electronic components I could lay my hands on, I built a single solution for Evelyn. This was a controller that worked with just one hand that she could use to play video games again on the PC. This worked great for her, but while she was looking for solutions online before we met each other, she met loads of other people with very specific disabilities that also couldn't access the amazing world of video games. So when we went out to ask these people if Evelyn's solution worked for them, it nearly did, but it didn't quite. There was always one small nuance that was different for every single person. So rather than imposing a solution upon people, we had Zoom calls with 300 different people, asking them what they'd like to see in a controller. When we compiled all this data, I realized that we could create a single quantum that could act as a modular block, essentially like Lego, letting the user create their own solution in a very easy way. This way, everyone gets their problem solved, and they can also solve problems for other people in the community by solving their own problems. Of course, in theory, one single block that you can build up to build any controller possible is fantastic. In practice, engineering isn't so easy, and you have to make something cost-effective, manufacturable, work from an electronic perspective, and also work from a mechanical perspective. You also have to consider safety, and you also have to consider breakability. So we learn this the fun way, by iterating continuously. The electronics in this device consist of a motherboard. On this motherboard, we use an ESP32 module, which has built-in Bluetooth. This is what allows the device to communicate to the Xbox, the PlayStation, the Windows, or the iOS device. The cube has a custom PCB attached to each face, which allows other cubes to connect to it. It has one custom male connector that uses pogo pins to attach on to the custom female connectors that we have on the 5 other faces of the cube, depending on the type of cube. These special connectors allow the male connector to connect to the female connector at one of 12 different discrete angles, increasing the number of possible combinations if you have 4 cubes to over 1 million. Finally, to create these PCBs cost effectively, we used a rigid flex structure where the male, female, and motherboard would all be made on a hard PCB surface, and they were all interconnected using flex cables that were built into the middle layer of each other PCB. The mechanical enclosure was designed to fit this rigid flex PCB format that we created. It also fits in a battery. And we ordered these from China to allow for quick turnover time and mass producibility. We also designed the mechanics to fit an LED around each ring for each peripheral connection. Once we designed these cubes and the electronics were working together, we had to make sure that they stay together in a rigid format. So to solve this problem, we designed a latching mechanism that works using 2 buttons on each cube, so the male connector clips in to any female connector at one of the discrete 12 angles, and to clip them out, you have to press both buttons at the same time. We currently have a patent filed for this connection mechanism, along with some other technologies that we have developed, such as the ID algorithm that we had to develop to allow the controller to know what configuration it's in. It does this by reading unique resistor combinations. So the male connector will have a unique resistor inside it to identify what type of module it is, and the female connector will have one of 12 different resistor values based upon the angle that the male connector connects through the female connector at. This hardware solution that we've developed is met with a suite of software tools. One of these tools is the phone app that we've developed for iOS and Android. This lets the user to connect to their controller using Bluetooth via their phone app and remap any of the buttons they want to on their controller. They can also share the controller configuration that they have built, which automatically gets uploaded as a 3D render onto their phone, which connects via the cloud to our website. So users can share with the community what their specific solution is. We also have an AI matchmaking tool where the user can input their specific disabilities and it matches them to an optimal controller for their needs. We also have a controller builder online, which is an interface that lets the user build their own controller using our full list of modules in a 3D interface to see if there might be a solution that suits them. This also brings into it a parametric configurator, so users can use our individual modules, but they can also create their own custom modules as long as there are no electronics involved. So just really quickly to show the commercial opportunity of this, there are millions of gamers worldwide that can't access video games due to their disability. Due to competitive analysis and talking to 300 different users, the solutions on the market today don't work for people. They're too clunky, they're not easy to set up, they do not have all these software supported features, and they're also too expensive. So the macro market in gaming is 200.8 billion, which is a huge market, and our target is 180 million disabled gamers in the US and the EU that need a solution for this today, which we are planning to offer this October in our soft launch, where we will sell 250 units per month via our supply chain, which we are also planning to build up through PCH International. Thank you very much for listening, and I look forward to any questions you have.
So thank you again to Brandon and the team from BioWave, and from myself, a massive congratulations to all the participants and all the finalists from this year. We've seen amazing projects being presented to you, and those which could have an amazing impact on society and individuals in the future. So obviously wish them all the very best luck in the development of their project, and hopefully take them to a place that we can all see in the future on a day-to-day basis. So now I'll pass it over to Michal to tell us about what's up next then.
Yeah, thank you, Pierre. And yeah, again, just to say thank you to everyone who entered the 2 competitions. There's some incredible finalists there. I don't envy the judges who just in a moment we're going to have to jump into the Zoom room and they're going to be grilling all the finalists on how the presentations went. The judges have some tough choices to make on who will be the winners of the 2 categories. So yeah, I'm really excited to see. Just as we're getting the Zoom room set up, we're going to play another message from our sponsors. And look, if you haven't got a chance yet to join the Zoom room, if you're only kind of tuning into the YouTube premiere right now, I'm going to drop the link back in the chat just now, just so everyone can join us. So yeah, again, another message from our incredible sponsors, Siemens.
How do you create the smartest university in the world? Bring a world-leading university together with a global technology powerhouse, and the possibilities are endless. Our world is evolving and technology is transforming the everyday, so we must continually transform. Together, the University of Birmingham and Siemens are starting the journey to create the smartest university campus in the world. Using cutting-edge smart sensor technologies, artificial intelligence and energy-efficient infrastructure, the university will become a living lab, capturing data across the campus and use it for innovation, teaching and research. Our goal is to deliver the campus of the future, enhancing the student, staff and community experience and accelerating the university's path to net zero. From Birmingham to Dubai, see how we are shaping the future of campuses through this energy and digital transformation journey.